to Along with the Dead, the first tutorial series in the channel, and I'm really excited actually to create a Left 4 Dead clone. I don't have too much to talk about, so we go straight into the engine. So, this is what we will see when you create a simple project for Unity 6.5, and I recommend the 6.5 that it's the latest version of the Unity. So, we have a lot of windows, so let's take one by one. So, the hierarchy. The hierarchy is the controller of the game objects in the series, so I just can right click into it, create empty, and I can rename it of course, and I can have a lot of game objects, like the map, the player, the weapons, and other stuff. So, we have the inspector. The inspector is the window that shows us what kind of scripts every game object that has, like the player movement, the weapon manager, and all other stuff. The project, that it's right down in the middle, it's the holder that has every asset, every audio, every script that we use for creating the game. The console, if we have some errors, the console will show us right away. Animations and timeline, we skip them for now, we don't need them. Project manager, of course, to add assets into our game. Animator, that we'll see it in another video, and the game view, what actually we can play and what the player sees. Okay, let's start straight for the player movement. We will use the Unity's new input system. So in the third option that says input system, we just press the generate C# class and we hit apply. When we hit apply, we see the input system actions. This is the script that will be based for the actions. For example, when I press the W, I go forward. When I press the S, I go backwards. You get the point. I will delete the camera and directional light and the game object that I created. So we have a full blank scene. We will just right click into the hierarchy, 3D object, and a base cube. This will be the floor for now. So the floor, for the positions we'll go for 0, 0, 0, and for scales into x-axis 10, for the y-axis to 0 because it's a floor, and for the z we go for 10. Okay, before we continue, we will use the ground layer for the floor, so when we write the script we will tell that where is ground, you can walk. So in the layers panel, from the default, we will press the add layer. In the user layer 3, we write ground, we press enter for save, back to the floor, layer, and we'll go for ground. Now the script that we will write, whenever it is ground, we will jump. So right click into the assets folder, create folder. We will name it player. Inside the players folder, we will create two different scripts. The first one will be player movement, and the second one will be the mouse look. We wait of course to compile, and mouse look for the second, and we go straight to player movement. We wait for the Visual Studio to open, and there it is. So I have my notes already, so we take step by step the variables and what does it do. The first one that we're gonna use is the Unity's new input system. So using Unity engine dot input system, so we take access to the new Unity's input system. For the holds, we create a separate folder inside the Visual Studio that it's called the region. It's kinda a folder that holds the variables that we need. It's not necessary, but it's for organization. The organization in programming is the first and the last alphabet letters. So region, variables, and region. First of all, I'm gonna create 3 private bool variables that each one is moving, so we will know when the player is moving. one private pool that it's running, so we know when the player is running, and one new private pool that we call is crouching, of course when the player is crouched. A header is the specific title in the inspector, and we can see better with it, and we call it movement. We need three variables: one public float that is walk speed, a public float that it's run speed, and a public float that it's crouch speed. So when the player just walks, we go to the walk speed. When the player is run, we go to the run speed, and when the player is crouching, we go for crouch speed. And of course, because we will have crouch, we need to adjust the height. So a header, a new header that we will call it height, and we go for a public float. I'm just watching my comments. Normal height, and one new public float that it's called crouch height. And we need of course a variable to change it, and a private float that it's called target height. We save, and we continue with the variables. Of course, when you press jump, you go up, and the gravity drags you down. So we need a gravity. So header, we've got jump and gravity. One public float that it's jump height, so how higher the player will jump, and the public float that will be the gravity, and the default gravity is 9 minus 9.12. And we need to check when the player is grounded. So header, we will call it ground check. Okay, so public transform ground check, this will be the game object that be in the feet of the player, so it will say if the player is grounded. A public float that will call it ground distance, how much we want the player to be from the ground in order to check if it's actually touching the ground. And a public layer mask that we call it ground layer. With this layer mask we can understand if it's actually sitting on the ground or in something other object. And for our last 6 variables, we need actually a reference to the character controller, that is the script that we'll use to move the player. So components. Trust me, everything is gonna make sense. Just follow me up with this one. Private character controller. No, we actually will go for public character controller, and we call it character controller. Public capsule collider, and we go for capsule collider, and of course public. Oh, this one is a private input system actions. This is where we can understand when the player actually presses the buttons, and we call it input action. And for movement, that it's a header movement. One public float speed, obviously. One private vector 3. The Greek already hit. Velocity. And the private bool that we can understand if it's grounded or not. We save here, and we go back to Unity. Of course, we wait for load, and our player will be the classic bin. Obviously, all the game starts with a bin, and we call it player. For this one, we will add character controller. This is the script that actually moves the object, and this is the Unity script. We want rigid body because this is a rigid body script that we will use to jump or go lower. For this, we go is cinematic true and use gravity as a false because we will use the gravity from our own script, so we don't need extra gravity. And for constraints, freeze rotation to z-axis because we don't need to do some weird movement. And add component, this is the player movement script that we have. And this is the variables. As you can see, the header, the height, the jump and gravity, the ground check components and movement are actually the headers that we created in the script. So, as a walk speed, we go for 3, as a run speed, we go for 5, and as a crouch speed, we go to 1. Normal height will be 2, and the crouch height will be 0.7. If we want to change it, we just change the numbers. Jump height, we will go for 3. 3 will be too many, so 1.5. As the ground check, we go for the player, right click, create empty. We name it ground check. As for the ground check, this will be into the feet of the player, so we'll go for the -1. Actually, into the feet of the player. There it is. Back to the player. This is where the ground check is. We just drag and drop the ground check. For the ground distance, we go for 0.3. And for the ground layer, we go for ground. For character controller, we go drag and drop the player. And for the capsule collider, also the capsule collider. We press save, and now we go back to the script. Now we will write actually the code that we will use to move the player. Let's start with the start method. First, we need to grab the reference from the input system. So input actions, that input actions equals to new input system, if I could write, dot actions. This is the line of the code that will tell us that we get the reference for the actual input system. We go for the save of the project and for the save of the player for a private void on enable and on disable. What is on enable and what is on disable? On enable and on disable are the two functions that runs when the object goes on disable and when the object is on enable. So the actual when it's toggle on, toggle off. Why we need this? Because we need to get the reference into the input system. So if we, for a cinematic or for actually gameplay purposes, we disable the character and we re-enable it, without them we won't move. So we actually want to move. And let's go for the update. For update, we go for this. We will create 3 different functions. One function will be the handle movement. This will be the function that actually moves the player. The handle crouching, that will handle the crouching methods, and handle jump and gravity, that it actually handles, as you guessed it, the gravity and the jump system. So perfect. We go now for the handle movement. We create a region that will call it handle movement and end region, and of course a private void that is a different action and a different mechanic. So private void handle movement. So hear me out for now. We need actually to add the velocity. So when the player presses W or S or A or D, it will go to these 2 directions, to H and Z axis. So we need a vector 2 that it's called move input, and this move input we will use the input actions that we created earlier, dot player dot move dot read value for vector 2. What this actually does, it goes to the input system actions, to this actual object, and checks the move buttons, so that we have the left stick for the gamepad if we want a controller, and the WASD if we want the keyboard. So with the W or up the arrow, S, A, and D. And you can see it's a vector 2 because all the axes are vector 2. So with this line of code, we just take the values 1 or -1 for the axis, and we need the vector 3 that we call it move, that it's actually the movement. Transform.right multiply for the move input to x-axis plus transform.forward multiply to input to y. So we can go front, back, left or right, and diagonally. Okay, now we need to assign these three values to assign the speed. So is moving will be true or false accordingly to what? To move input dot sqr magnitude equal, not equal, higher than 0.0001. What's actually mean? That means that is moving becomes true when the player is moving to the direction that we don't really want to know. But actually, if the player is moving, this moving becomes true. So what about running? The is running will become true only if from input actions dot player dot sprint dot is pressed. And again, the is running will be true or false accordingly to the is sprinting. Where's the sprint? There it is. The sprint. That sprint it's left shift from the keyboard and left stick press from the gamepad, or the trigger for the extra controller that it's actually for the VR. No, we don't do anything about it. So we continue. And this crouching will be from the input actions, as you guessed it, dot player dot crouch dot is pressed. So we know now if the player is running or is crouching or is moving in general. And now we assign the speed. If is moving, that it means that if it's moving false, speed equals 0. Else if. So now we will see if it's crouching. If it's crouching, that means speed equals crouch speed. Else if what? Is running, that means speed equals run speed. Else, that means if the player is moving but not is crouching, not is running, speed equals walk speed. And in order to save some lines, we can just do that. So we know now when the player is walking or running or crouching, and we assign the values. And now we need to move the object. We assign the values, we know the direction, now we need to assign it. So we go to the character controller that we used earlier. Character controller dot move, but where? To move, that's the transform. Multiply the speed, multiply to time delta time. That time delta time is actual the game time. Time delta time. What is the time delta time? As a line. The time delta time is the, how can I explain? I found it. Even the game runs in 120 FPS, even in 3000, that it's actually weird, or 60 or 40 FPS, the movement will be the same. The time delta time is actually the sync from FPS to actually gameplay time. Now, we go for the crouch. Region handle crouching, and region, no, private void handle crouch. Perfect. Now, is crouching will be equal from the input actions. We'll check it again. Input actions dot player dot crouch dot is pressed. Perfect. Now, if it's crouching, that means we need to assign the target height, the actual height of the player. So target height equals crouch height, else, that means if the player is not crouching, target height equals normal height. And now we just fuse the colliders. We actually gonna go to the capsule and the character controller, and we will change the height value. That means that we actually shrink the player or lengthen the player. And we will do that like this. Character controller dot height, we change the value of the height, equals mathftlalerp. Mathftlalerp is the function between for two numbers, and we change the values between them with the time. So mathf.lerp, it's actually some Greek words coming right away. Character controller dot height, and with target height with 3f epi time delta time, multiply time delta time. The 3f multiply the time delta time is actually that we need in 3 seconds to go from the character controller's height, the number that it's inside saved here, to the new number in 3 seconds. And we do the same for capsule collider. Capsule collider dot height equals capsule mathf.lerp, capsule collider dot height to target height 3f multiply time to delta time. And that's actually pretty much it for the handle crouch. And for the last, we go for the handle jump and gravity. Region, we just not do like that, and region. So private void, the same name. Be careful with the names. They must be identical to know each other. So is grounded will be equal, so if it's the player is grounded or not. Physics dot check sphere, so we create a sphere around that position. We actually create a sphere around the player's feet, and if that sphere that it's created in ground check dot position with the ground distance, and we'll check the ground layer. So if is grounded, come on, I want it. If is grounded and velocity, that's actually the gravity that takes the player into y-axis, it's less than 0, we go for velocity into y-axis equals to minus 2f, that's actually we drag the player. And if what? If input actions dot player dot crouch dot is pressed and is grounded, that it's That's actually the player is grounded. You go for velocity. Velocity to y-axis equals mathf dot sqrt. That's actually the jump height. Multiply -2. Multiply the gravity. This is where we drag the player down. And go for velocity dot y equals, plus equal from gravity multiply the time delta time, because we want the gravity drags the player down smoothly, and character controller dot move velocity multiply time delta time. And that's pretty much it for the basic character movement. But before we leave, we need to change, and instead of if input.action.player.crouch, this is where we jump, but I just assigned the crouch button. Of course we don't need that. We go for jump, and we go for notice pressed was pressed, this frame, because we need to check when it's pressed. And we go back into the start, and instead of void start we go for void awake. And for on enable, instead of creating a new input actions, we need to enable the action. So input actions dot player dot enable, and of course if we disable, we need to disable the actions. So input dot actions dot disable. We press save, and we go back to Unity to see if the player is actually walking. But before we test it, we need to go into the input system, and we need to check if the crouch is in left control binded. If it's not, if for some reason it says C here, you go into the path, you press the left, you press the crouch, the C, you go to path, and you find the left control for keyboard, and you assign it, and you press save. Of course we wait for Unity to modify it, and we press play. Now we have a character that actually can walk around, it can run, it can crouch, and it can jump. As we can see, the gravity is actually pretty good for now, and we keep it like that. Perfect. Now give yourself a tap into the head, because you actually managed to do it. Now we go for the camera. We need the camera, of course, to rotate with the mouse, and we need to rotate the body. So let's create the camera. Right click into the player, camera, and we name it, we leave it camera. We will change some stuff into the camera, so we go for the near for 0.01, and we move the camera all the way down to 0.7. Now we go to the player, and we open the mouse look script. Now we need to write the actual code that rotates and the player and the camera up, down, or left, or right. So as we need the input actions using Unity engine dot input system, of course a region, and we name it variables, and end region. Now private float what? Private float mouse X, that it's the rotation into the X-axis, and private float to mouse Y into the Y-axis. We need a header that it's called for sensitivity, so we call it sensitivity. Okay. Now public float mouse sensitivity, and public transform, that is the player body, transform player body. And of course, let me check. And one more, that it's the rotation of the axis. Private float x rotation. Perfect. And the input actions. Private input system actions, and we name it input actions. Now again with the same setup, on the awake we go input actions equals new input system actions, and on void on enable input actions dot player dot enable, and of course on disable, I'm really sorry for this, private void on disable input actions dot player dot disable. Perfect. Now we go for the rotation. So we create a region that we call it camera code, and region, and we go for that. Vector 2, we will name it look input, and look input will be equal to, let's see, input actions dot player dot look dot read value, and as vector 2. That's actually will read the value from the mouse, that it goes left, right, or up and down. As a mouse X will be equal to look input into x-axis multiply to mouse sensitivity multiply to time delta time to be smooth accordingly to FPS. Mouse X as well, mouse Y, sorry, equals to look input dot Y multiply to mouse sensitivity multiply to time dot delta time, and X rotation equals minus equal to mouse Y. This will be the reverse controls. So if in your PC it goes upside down, you just, instead of minus equal, you go to plus equal to mouse Y, and goes, it depends on the mouse. Sometimes it works with a minus, sometimes it works with a plus, and I'm confused as well. X rotation equals mathf.clamp. The clamp will take the actual rotation and assign it. X rotation, and we hit the limit, minus 90 and 90 degrees limit and minus 90, so we go just here and almost here. And now we assign the player body. Player body dot rotate to where? Rotate to vector 3 dot up multiply to mouse X, and transform dot local rotation equals quaternion dot Euler to X rotation to 0 0, and actually pretty much it to rotate the camera and the player body. We save, we go back to Unity, and let's add into the camera the mouse look. As for sensitivity, I go to 100, and for player body we go for the original player. We press play, and as we can see, we can rotate, we can look around, we can walk wherever we look at, we can jump, we can sprint, we can crouch, and that's actually pretty much it. And I want to add 2 lines of code to disable the mouse. So we go into the awake method and we go for cursor.visible equals false and cursor lock state equals cursor lock mode.locked. That means that we lock the cursor only into the middle. Save, we go back to Unity, we press play, and we're finally done. We have our character that can walk around in 3D, it can look around, it has modular sensitivity so we can lower or increase it. It depends of course with your mouse. And we can have the character that jumps around, crouching of course, and running. Okay, I leave it here for now. It's a great start. You created the character, wanna walk around the 3D environment. For the next video, we will start adding weapons, so we can have actually pew pew, reload, sound effects, and other stuff. I will add into the description the GitHub link, so you can just go and grab the project from there, or you just clone the project instantly, and you can just do a pull whenever the changes are coming from the videos. Anyway, the next video will be maybe Friday or Thursday, I don't know, we will see. So like of course because it helps me out, subscribe if you're not subscribed, comment what's the best part of the video, and I will see you in the next video in the lives. See you for now.